Welcome to the first talk in the small theater, Theater 7. I'm pleased to introduce, without any extra words, Jeffrey Capobianco from Moody's, who has so much to tell us, he needs all the minutes.
Product manager of search for Moody's.com. Turn that down a bit. Very excited to be here because Haystack's been a big inspiration for me over the past few years. More recently, I've had the honor of contributing to the Moody's Research Assistant, which is a chat application for financial analysis. It's been an amazing collaboration of multiple teams working at a very fast pace. And though it's cliche, we like to say that it takes a village. So we'll help you lay out a plan to create a transformational retrieval augmented generation application in a short period of time. Let's start with a story. Our story at Moody's begins with a very talented and driven AI whisperer by the name of Sahil Haslani. And Sahil worked late into the night building a chat application that accepts freeform questions and responds using Moody's data. Before long, both leadership and investors alike became very excited about this easy-to-use, delightful experience, and maybe more importantly, its time-saving implications for our users. So, the search squad joined forces with the research assistant squad so we could work together on scalability and on iterating on answer quality. Which brings us to today. The Moody's Research Assistant is live in production with a growing amount of traffic and a growing number of paid subscribers. It can answer a wide range of questions about organizations, their credit ratings, financial data, and broad-based sector questions. It provides citations, relevant charts, and suggests follow-up questions to guide your research journey. So we'll share some of the knowledge we gathered along the way. And some of these lessons came from quick wins. Others are from the benefit of hindsight. Hopefully we'll help you avoid learning some lessons the hard way. We'll go over this in 4 main sections. First, nobody likes a solution in search of a problem. So we'll give you some tools to help explain to your stakeholders the value of RAG. Then we'll all get on the same page about what a system like this may look like, some of the big building blocks to which we'll refer back throughout the talk. And then part 3 is going to be the main portion, where we talk about setting a foundation, the things you should invest in early on so you can iterate quickly on top. And then very briefly, we'll talk about some areas you can explore next and build on top of that foundation. So why would you build a retrieval augmented generation app? I'm guessing I'm not the only one of us to learn that CEOs really want AI. And then it's up to us to figure out how to make it work. There's a Deloitte study, which I'll reference in the appendix, that shows 8 out of 10 leaders expect AI to transform their organization within 3 years. And RAG can be a wonderful bridge between that desire and real value for your users and therefore your business. So here you can see our credit analyst with a big stack of relevant data that we provided from Moody's. And instead of reading through this wide swath of data and synthesizing a response for their needs, the research assistant does that for them and automates one more step of their journey. So especially in our business-to-business setting, time savings is the real product. And research assistant users save up to 27% of their time performing financial analysis. So that frees them up to do higher value tasks. And you get that time savings through this easy to use tailored chat experience that's rooted in our factual trusted data. And we enable this by getting the best of both worlds between a search engine and a large language model. And what do we mean by best of both worlds? Well, with search engines, it's a well-studied problem of getting up-to-date information indexed into your system as it's published. And that data you're indexing probably sets your business apart from others. With an LLM by itself, it's very challenging to train new data and new information into that model. It takes money for compute, it takes time to complete, you need a high level of expertise to do it effectively. And even once you train it with that data, it can still give responses that are outside of those facts. It can still hallucinate. Now, in some applications, these generated musings from large language models can be really powerful. If you think of things like image generation, creative writing, brainstorming, you wouldn't even call this hallucination. It's a great feature of the LLM. But for us, we need to provide trusted data from industry experts, so AI really needs to stick to the facts that we provide. Sometimes when I'm interacting with an LLM all on its own, it kind of makes me think of some trouble I would get into when I was younger. I was a very confident young guy, and when I was asked a question I didn't know the answer, instead of saying I don't know, I would say, oh, this sounds plausible, maybe it's right, and I would give my confident answer, and people would often believe me, and then before long, I would get into trouble for that. And you can get yourself in the same trouble if you try to train a model and send that out in the world and represent your company. You know, there have been some cases in the airline industry, in automotive retail, where there have been real financial and reputational damage because chatbots went off the script. So mitigating and preventing hallucination is a key component of RAG. Going back to the search engines, as we saw in the image, users need to synthesize a response together from a lot of sources. And for those of us building the search engines, getting the full user context can be very challenging. You need to master a lot of techniques, wrangle a lot of data. With LLMs, they're very context aware and they can answer very specific questions right out of the box. So by retrieving data from a search engine and then generating a response with an LLM, we aim to get all of these desired behaviors and leave behind some of the drawbacks. We get some net new benefits as well. We spoke about the synthesis element, and we can also suggest follow-up questions to which you know you have the answer because you generate them from your data. But it comes with new challenges as well. These systems have a number of moving parts that all need to work in concert, and measuring that ensemble can be very difficult. And we'll talk about that in detail. So I'm sure there are a lot of use cases for RAG, but from our perspective, it's very focused on freeing up knowledge workers for more high-value tasks. And so if your business checks some of these boxes, there's probably a good case for RAG for you. So how do you actually make a system like this work? We'll go over some of the main building blocks. Starting at the top with our chat interface, of which we saw the screen recording a few slides ago, a user can answer any question they'd like, any prompt they'd like. And the first step along that question's journey is this intent detection layer. This box is green to denote the opportunities to use large language models. And this intent detection layer can make your search engine's job a lot easier. It can filter down your space. It can route different kinds of questions to the best suited data sources. And so it's going to send queries to your search engine, to your structured databases and APIs. And this little trio in the bottom left here makes up the retrieval portion, that R in RAG. It needs to be able to handle long queries. It needs to get relevant chunks of data that can fit into the large language model's context window, that max number of tokens it can accept in a prompt. So once you've retrieved your relevant chunks, you bundle them together into a prompt, you send them to a large language model in this response generation step, like GPT or Claude, and then you stream your response back to the user. So everyone's on board with the value proposition, you know the high-level architecture. Where should you focus first? We're going to talk about laying a foundation for fast iteration and some upfront investments that can save you time down the road. We're going to talk about 4 cornerstones to tackle early. 1, understanding cost. This could be the most expensive software to run at your company. 2, measuring this ensemble of inputs and outputs so that you avoid a one step forward, one step back relevance tuning experience. 3, we'll talk about detecting intent, which for us at Moody's has been one of the most crucial aspects to our success. LLMs unlock big opportunities in this area. And 4th, preventing hallucinations, so you gain your users' trust and you leverage your differentiating data. So understanding costs. I want to help you avoid an uncomfortable spot where your project has progressed along only to realize it's not financially sustainable for your business. On the other hand, maybe you have colleagues who've had a knee-jerk reaction that an AI application is too expensive to run, and you can do some estimations to help them understand. There will be 1 or 2 areas of new cost in your stack if you don't have an app like this today. The big one is large language model providers, these boxes in green, companies like OpenAI and Anthropic. And if you're not doing dense vector search today, and you certainly don't have to do it in order to build a RAG application, but if you want to add that into your stack, then creating embeddings, those numerical representations of your data, that's going to be a new source of cost as well. APIs like GPT and Claude, they charge per token, and they have their own tokenizers. OpenAI's website has this tokenizer tool where you can paste in chunks of data, prompts, responses from LLMs, and understand how many tokens they contain. And you can see it'll color code them for you, which is nice to help you gain some intuition. And the tokens you send in the prompt are priced differently than the ones that come back in generation. You can see some examples from OpenAI and Anthropic where generally the generated tokens cost twice as much as the ones you send in a prompt. So a pretty simple formula emerges. You need to know the number of tokens in your prompt, multiply it by that price, and the number of tokens you expect back in the response, multiply by that price. And you can even set hard limits on the number of tokens that come back in your response through these APIs. So let's look at an example just to get some numbers. You'll need to look at your use case and your data to pick token volumes estimates. But let's say you use a 4,000 token prompt. That's going to contain your instructions to the model, your retrieved chunks, and the user's actual question. And expect around 300 tokens to come back. That's our box on the right, the response generation. And you probably have a smaller intent detection prompt. Let's say it's 300 tokens and gives back a small 30 token JSON. So you sum those up, and then you can start looking at the different providers and the models they offer. You can see how a larger, smarter model like Claude 3 Opus or GPT-4 Turbo are going to cost between $40 and $60 every 1,000 requests to your application using the token volumes we estimated. And a smaller, faster model like Haiku or 3.5 Turbo are going to cost between $1 and $2. So there's a really big difference there. So it's worth spending some time experimenting to find the smallest, fastest, cheapest model that can give you the accuracy you need. And you can mix and match for different use cases. Maybe use a large smart model for your final generation, a small fast model for your intent detection. You want to leave some headroom in these volumes estimates, the number of requests, because you're going to need to do development, experimentation, automated testing. You might want to add more tokens to a more complex intent detection layer. And then the other portion we spoke about is vector, creating your embeddings and vectors. And again, you don't need it. It's not a must. But for us, we found it was very helpful for these long question-like queries and for out-of-vocabulary words. So we decided to add it into our stack. And if you do the same, you'll need to create embeddings for your chunked up data that you ingest and also of the queries that are sent to your system. Most of your costs will come whenever you rewrite a large volume of data into your vector database. So you should set very clear expectations with your business around how much it will cost to rewrite everything, what's the smallest valuable set of data we can make searchable to start. Because if you change your model to create embeddings or you change the way you chunk up the data, you need to rewrite everything, and that's going to be the biggest cost source. If you use a third-party provider like Cohere or OpenAI, it's again a per token pricing model. It's much less expensive than generation. But if you need more flexibility, there are tools like SageMaker where you could host your own model. You can use an open source one. You could train your own. It's very flexible for different latency needs. For us at Moody's, we're committed to making data searchable 15 minutes after it's published, so we need strong guarantees on throughput, and we've been experimenting with the serverless, batch transform, and real-time options from SageMaker. So your business understands the estimated costs based on the volume of data you estimated. It's time to start building. Let's move to the second cornerstone, which is measurement. If I could go back in time, I would have started this observability aspect even earlier than we did, and we started it pretty early. If search relevance can be a game of whack-a-mole, you fix one query, another breaks over here, RAG can be like the 3D chess of whack-a-mole, because there's just so many moving pieces in concert. And as I learned more about measuring RAG systems, this image of probes kept coming into my mind. By a show of hands, anybody have an electrical engineering background, either professionally or education? Okay, nice. I personally ran for the hills of software immediately after clawing through my EE degree, but I digress. The goal is to really enable rapid experimentation with this approach, so you can iterate much faster. And we're going to talk about some of those windows you need into your flow so that you can keep making improvements without regression. First, end-to-end. See, we have our negative probe on the question from the user, our positive probe on the final generated response. So you'll need to measure the relevance of these pairs. This is what matters to your user, so it should be a crucial checkpoint before you release to production. But when problems arise, it's probably going to leave you with more questions than answers. So you need to measure the intermediary steps as well. Moving along our circuit here, the next step is that intent detection layer. And this will probably have a number of steps depending on the queries you expect and how your data looks. You should measure each one individually as well as the ensemble. And depending on your use case, a lot of these are probably measured like a classifier. Now this one's crucial. This is one we learned the hard way. You have to have a test that looks at the full retrieval phase. I don't think I need to tell the Haystack audience how important it is to measure your search engine in isolation, but it's not sufficient. If you just look at the search engine phase, you could end up measuring queries that are actually different than the ones you'll receive in production, missing some pre-processing step. Or maybe you're spending time optimizing queries that are actually just routed over to a relational database or something. So having this full ensemble tested together, the input from the user, and then the retrieved chunks that come from this whole trio here is crucial. And your teams will be able to iterate a lot faster if they understand how these layers interact. Also, if your test bed can accept changes from both, you'll be able to experiment in parallel. So it's a bit of a twist on the query doc pair measurement that we know so well. Large language models can't really scroll or paginate. They have one chunk of data they can accept in their prompt, and they actually have some capabilities to discern relevance. So your goal is to fill the context window with relevant chunks of data. And for this task, I think precision at K is a great primary metric, but it's always important to avoid having blinders on gaming one stat and getting a holistic view of your system. So having some ranking-aware stats, like ERR, is really valuable as well. If you think about this border, at the end of the context window, if you swap the ranking of a good and bad result there, that could be a big difference maker in your final response. And lastly, you want to look at how faithful your generated response from the final LLM stays to the chunks you retrieved, right? People want your proprietary data, want your differentiating data. They don't want something that came out of a foundation model that has a low barrier to entry. There's a number of tools out there to measure these kinds of systems. I'll probably have a new LinkedIn message when I go back to the hotel this evening about one that came out. You could build your own. One of them is Langsmith. There's a screenshot from their evaluation tool, and you can see these columns on the right represent the steps we just spoke about. The overall score, how faithful the response is to your retrieved data, and the quality of your retrieved data. And whatever tool you choose or build needs to be able to run batches of queries, and you need to be able to see performance at those different stages. And again, setting up your code to work with your test bench early can save you time in the long run because it's always hard to make time to refactor once your code's out in the wild. So you may have noticed that this is a very data-hungry problem. There's a large number of steps that need annotations or judgments. And in my case, I'm certainly not an expert on financial analysis or credit products, but we still need to support that domain as a team. And our search engine, our previous search engine, wasn't really optimized for question answering, so we didn't have a lot of implicit data to go off of. So we needed to work with our experts. Their time's expensive, they have other deadlines and incentives to worry about. And when we can get their time, this question and long answer judgment is much more mentally taxing and time consuming than looking at a keyword in a document title, for example. Plus, since we're chunking up our data, just the number of possible pairs that needs annotations is really large. So we use a large language model as a proxy. It's not an expert, but it can save you a lot of time. And if your business and you understand the risks, it can be very valuable. Again, here's a screenshot from the Langsmith tool. They have a hub feature, which has a community providing different prompts for different tasks. You can create a private hub just for your business. And you can create your own custom prompts to fit your domains, which is what we did. Also, you can consider adding a relevance scoring element right into your final generation prompt. It's going to increase your production tokens a little bit. It needs to stay super simple so you don't confuse the main task. So it's not something you can rely on for fine-grained relevance scoring, but it can be a really nice coarse-grained indicator that there's a class of problems that are not going well, or a class of queries that you're not answering well, even if users don't give you that explicit feedback. And it's really, really easy to incorporate this into your logging versus separate offline process. But if I could get another show of hands, who is skeptical about trusting an LLM to say whether you're doing a good job, whether relevance improves or decreases? Okay, less than I thought. There's some believers out there. Well, we were really paranoid about it. We didn't know if it was going to understand the financial language, the task at hand. Was the time savings worth the accuracy risk? So we did a one-time exercise where we worked with our experts to provide annotations on different problems. And then we sought to answer the question, does the AI agree with the experts at least as well as they agree with each other? And you can use some stats like Cohen's kappa to measure this, but we found one of the best ways to get everyone on the same page is plotting out that data. So this is for a particular query chunk relevance judgment set. And you can see there's 3 labels that the experts or the LLM prompt could provide. That's bad, fair, or good, 0, 1, 2. And each bar is a different judge. The red one is our prompt. And the vertical is the number of annotations they provided over the whole data set for each category. And you can see that the AI is much more likely to give a so-so answer than the experts were. So you can regroup your data to improve agreement. Now this is going with a strict approach. Strict meaning that bad or fair, we put those together and we only care about improving good chunks, which, like we said, that's our primary objective. So we lose some information about those incremental improvements and regressions between bad and fair, but we're okay with that because our goal is to get all good chunks, and it gives us better trust in our automated offline system. But what if no matter how you regroup the data, you just can't get the experts and the LLM to agree? Well, there are a few prompt engineering tricks that really helped us. And one of the biggest needle movers was making sure that the prompt explains and then scores. A large language model is picking the most likely token, generating the most likely token one after another. And so if it gives you a judgment and then an explanation, it's just going to justify that token it already generated. Where if you use these chain of thought techniques, you tell it to think step by step, provide an explanation first, it has a bit more logic to go off of. And we found this was the biggest change in getting our LLM prompt to agree with our experts. Also, you can provide some few-shot examples with explanations from your experts on why they judge certain query chunk pairs. And you should give similar instructions to the model that you gave to the humans. So your most crucial cornerstone is set. can diagnose issues, you can measure improvement, you can see which pieces of your system need the most work. Let's talk about the two more key components to your foundation. Now, a lot of papers and blogs that I've personally read seem to gloss over this intent detection component, but it's been one of the most crucial aspects to our success on the Moody's Research Assistant. LLMs are making a lot of these techniques much easier than they've ever been before. Full text search is hard, which I think is why a lot of us enjoy it. You can use some clever prompting to thin out your search space as much as possible. We were able to make the search engine's job so easy that we went to market with open source, off-the-shelf embedding models that we did not fine-tune. Also, you can work with your colleagues who know, where do I find the answers to certain types of questions in our data? And you can encode that knowledge into your prompts. Let's look at an example. Here's a use case we absolutely need to support. A user is asking about a particular organization's credit rating, and they want to know how it changed and why it changed. So let's look at 3 different queries we could use to retrieve this data. 1, we could look at our corpus of expert research, long-form research from financial experts, broken up into chunks, millions of chunks, and you can just create an embedding of the initial question from the user, do a KNN search using OpenSearch. In an attempt to improve precision, we could add a filter to that query where you're only looking at documents that are tagged with that organization's ID from the question. Or 3, could do away with all the finicky natures of full text search, write a SQL query to our ratings database where we have an ID in a particular column, and sort by a date. If I get 1, 2, or 3 fingers, which query do you think is going to most reliably get our ratings data? 3. I see a lot of 3s. I agree. That where clause is going to be much more predictable than a full text search technique. But it's not going to give you that context from the experts that our users wanted. So again, 1, 2, or 3, which query do you think is going to most reliably, I see some quick answers, I love it. Which one do you think is most reliably going to get our context? Yeah, number 2. We'll filter out noise about other companies and we'll get the most relevant chunks about the task at hand. So you can combine different data sources to make that magical AI experience. But how do you structure these queries, or how do you construct them rather? Well, I want to call back to one of my favorite Haystacks from 2022. If you haven't seen it, go check it out on YouTube. Bojan Bobic spoke about AI-driven search. And I am very impressed with Nexor's architecture and how they incorporate context into the query. With techniques like query expansion, named entity recognition, query classification. These techniques are very powerful, but they're also challenging. You need to wrangle data, train models, and deploy them out into production. With LLMs, you're able to leapfrog a lot of these difficult tasks because prompt engineering is just a really accessible art, and it requires a lot less expertise in training models. Now, this approach is going to come at a cost. We spoke about the financial aspect. It'll probably be slower than something purpose-built for your task, but you can get to market very quickly, and now you've set a benchmark for your purpose-built systems. I just want to reiterate that baking this kind of technology in early was crucial to our success about that magical AI experience and getting to market really fast. Let's move on to our 4th cornerstone, guarding against hallucinations. You want to avoid our app acting like that overconfident teenage boy, right? Our users at Moody's need factual financial information from experts, not an LLM-generated response. It's very important to them. We need their trust, and the system needs to be able to say, I don't know, when the answer is not in your data. OpenAI provides a full prompt engineering guide, and we're going to talk about a couple of these that are important for that final response generation step. First, use delimiters in your prompt to the model so it's really obvious. Here are your instructions, here's the reference data, here's the user's question. Make it easy, make it unambiguous. Now this one's crucial, so important. You need to explicitly tell the model to only use your reference text. And if the answer's not in there, say, I don't know. If you think about the broad swath of data LLMs are trained on, there aren't that many how-to articles or blog posts where someone asks a question and then there's a response, I don't know, right after. It's just not what they've seen. So you need to instruct it explicitly. And this is a slightly doctored example from OpenAI, but it's very optimistic about the performance of a single short instruction. So you'll need to get a little creative and not be afraid to be heavy-handed to make sure it's only sticking to your data. Lastly, it's another small step from there to reference the citations, the cited data. It has to be a particular format so that your UI can recognize it and make it really easy for users to click back and forth to the source data. These APIs are going to provide a temperature parameter. Like we said, it's generating the next most likely token. A high temperature is going to add some randomness into that selection and sampling of tokens. So a high temperature can make a more robotic, or less robotic, more creative sounding response. But we're not after creativity. We're after a faithful response to our data. So you'll probably want a temperature of 0 or very close to 0. This is a rapidly developing field with lots of resources. I mentioned the OpenAI guide. Here's a few others you could check out. So your foundation is set. You understand the costs. You can measure improvements, diagnose issues, and prioritize different parts of your system that need work. And you understand the user's intent, and the responses you're giving back are faithful to that data that makes your business special. So it's time to get feedback as quickly and with as little risk as possible. Your app should be able to accept feedback directly, and you can take this feedback from your content creators, from your salespeople, from your data experts, and encode that back into your intent detection prompts. Just like the offline testing we discussed, it's important to log all of these inputs and outputs so that you can see where things are going wrong. Maybe you'll see a question from a few weeks ago that still looks broken, but it turns out it's broken for a different reason, so you prevent yourself going on some wild goose chases. And then you can prioritize and iterate. But you should definitely be careful about overfitting to your internal users, because if your experience is anything like ours, your subscribers will ask novel things you couldn't have anticipated. And once you've set this foundation, there's a few areas that you could explore. I think it's really tempting to dive right into some of these more advanced techniques, but you really don't need to fine-tune a model or re-rank if you have a really effective intent detection system. At least that was true for us. This approach is all about getting something usable, getting feedback, and taking it to the next level. So for us on the Moody's Research Assistant, we're about halfway down this list right now, and we're very curious and optimistic about LLM's capabilities to choose the most relevant chunk out of a list like a human would. All the images in this talk were generated using Microsoft's Copilot Designer tool, and all of the studies and resources are linked here. So thank you so much for listening. Thank you for the time, and any questions are welcome.
Thank you, Jeff. Thank you, Jeff. Okay, let's try that one more time.
You did.
And for those playing along in the Zoom version of the game, please type your questions in the chat box. I'll be moving through the audience with the microphone as quickly as possible, starting down here.
Thank you. Great talk. Really quite informative. I have lots of questions, so I'm gonna choose two for prime time. Okay. The first one is something that you mentioned about your metrics. You said it's important to look at precision at K, right? Not recall or ERR. And as we've been working with customers, I'm from Aaron. We've found that looking at recall works pretty well. And so I'm just curious as to why precision in your particular use case. So that's the first question. The second, okay, sure. That's all I got.
Sure. Yeah, I definitely don't espouse an approach where you only look at one metric. You should always have a suite. That's something that Ella Jakubowska taught me back during our training. You want to avoid those blinders so you have a full picture. But I think it's important to have one primary objective that you can use to really measure your improvement. And if that one's not met, you might want to rethink what you're doing. And the reason I think about precision at K is because you have this limited space to fill, and the goal is to get them all quality results. And no matter what you do, well, context windows are growing larger and larger with new models, but you're always going to have a limit to what you can fit. So that's why I believe that that precision metric is important, because there is like a maximum size you can fill. So you want to try to get every single chunk that you fit into that prompt high quality. But I definitely don't say you should ignore recall. I just think it should be more of a secondary stat.
From Alexandra Feinberg, how do you deal with latencies? Isn't the several stages system too slow for users?
Yeah, it's definitely less speedy than a traditional search experience. And we still have our search experience for those people who need information really fast with maybe a bit more of a straightforward information need. So we have some animations on the screen while the steps are calculating ahead of time. And then we also stream the response to users. So as soon as that final generation step starts, users are getting feedback and can start reading. Also, those earlier LLM steps, we have been looking a lot at smaller, faster models like Haiku. They're cheaper and they go a lot faster than something like GPT 4.5 Turbo or Claude Opus.
Great talk, thanks.
Thank you.
Just wanted to ask about some of the actual engineering behind this project. Like some of the tools that were used, specifically when you're talking about generating the vectors for the whole data set to do RAG. What did you use to get to generate them, to get them into your search index? I've been in the experience that sometimes that can be the longest part of a project, is actually generating those vectors, and if you have to change your chunking strategy or your model, reprocessing that. So just curious, like, what do those iterations look like? How is that experience for you?
Yeah, great question. So we use off-the-shelf open source model, which, to be frank, has become a little outdated at this point, and we're getting ready to experiment with some newer ones. We use AWS SageMaker to host the model, so we don't have to worry about so much of the hosting overhead and administrative. And yeah, like I said, it's really important to try to keep your data set small at first. That way, the time and financial cost of rewriting everything, if you try a new model, if you break your chunks up in a different way, which has been really important for us, you can optimize that chunking for retrieval and for the generation. You can even decouple those things. And so, yeah, we found that there's a few different options from SageMaker that we've been playing around with. The batch inference and serverless have been really good options for our ingestion, and then the real-time options are good for the faster requirements of query embedding. So, yeah, it was very largely built around SageMaker, and then using a lot of our standard relevance tools, plus some new ones we built ourselves to just look at that query chunk relevance.
And from Habib Shopejo, it's from experience, do you have any tips on how to avoid overfitting to internal users?
Well, you have to time limit your internal beta for sure. And you have to take a good look at the questions which are coming commonly, and then work with your business experts to know if this is something your real user might ask. And before you go optimizing for those, it might be time to get some paid beta users, or free beta but external users, so you start to get those questions from your real use cases as quickly as possible. But there's no way to know what your real users are going to ask until you let them in.
How do you prompt for query intent? So you said you want to determine what the user's intent is, what the query intent is, but what is your prompt? Do you use functions? Do you use plain language?
Good question. Good question. Getting dangerously close to the secret sauce, so I'll have to be careful about what I tell. And you can talk to me about joining Moody's if you want to know more, but generally we want to take the pieces of information that are crucial to many different types of questions, let the LLM extract those, and then we use those as inputs to our other systems like the search engine, like our APIs. And we generally go with the approach of just getting more data. And there's different schools of thought out there about whether you should only fetch what you need, or you could fetch everything and then have a post-processing step to thin down to the most valuable. Both have some pros and cons, but generally it's pretty plain language and JSON responses.
Great talk. So I'm wondering, you are saying about combining the structured data with search engine, right? So how do you handle that? Do you do it for every question? And what do you do, do you call search and structured data and then post-processing them? I'm a little bit curious about that part.
Sure. Good question. Let me just pull up that slide. So like I said, you want to pull out these pieces of information that are crucial for a lot of parts of your questions. And then you can use those as inputs to your systems like your search engine, your APIs, your databases. If you try to choose only the ones that will matter for that question up front, do some kind of like question classification, that's one approach. It'll definitely save you some round trips and some latency, but it can have some negative recall impacts versus if for every system that you are able to glean an input, you go fetch the data, and then you have something that post-processes, maybe another prompt, small model. It's a bit more heavyweight, but more risk-averse on hurting your recall.
Pardon me. So I had a couple on this side.
Yeah, so you referred one of the slides regarding the using LLM to judge the relevance offline, right?
Mm-hmm.
So would you like to add anything on why not using LLM for measuring the relevance or measuring the final response online? So for example, when the user is asking a question, using the LLM as the judge, based upon that, reiterating the answer or checking for another retriever type so that you get some other answer, and then improvising the answers just online when the query is happening. Was there any experiments behind that online experiments?
Sure. Yeah, we actually do that actively. There is a relevance scoring component to our final generation prompt, but you're gonna have to keep it so simple so that you don't confuse the LLM about what its main task is, which is synthesizing response based on your chunks. And keeping it really simple is going to prevent you from techniques like this where you have it give a big explanation and then you give it lots of few shot examples. So an offline process that doesn't slow down your user experience and doesn't add to your production token volume can be really powerful to get that more fine-grained relevance scoring, where this more of like an online approach right there in your response generation is more of like an alert signal, like whoa, a bunch of these are coming back with terrible scores. What's going on here? What's this class of problem? And it's not going to be able to give you like that fine-grained, this one got a little better, this one got a little worse. Also, it's just super easy to add into the prompt, so I do recommend that because you can just log it right alongside of all your other data. But it's much more complex to build a system that for every real user query, you do this full offline process. We might invest in that soon, but yeah, I think a blend of the two can give you that accuracy and that ease of implementation balance.
Okay, I have 2 questions left in the time we have.
Thanks. Quick follow-up on the query intent detection. Does that involve any retrieval? Do you use facet data or any kind of classification of the query before you try to do the query intent?
There is some retrieval involved, especially like identifying certain named entities. And yeah, so it's all about kind of isolating those data points that are going to be important to filter down your space.
And our final question.
Great presentation.
Thank you.
I had a question about the response generation. So you showed a list of different LLMs that could potentially be used. Do you do something where you potentially send some queries to the more expensive models and then others to the cheaper ones based on like previous learnings? And then maybe you can do A/B tests like that and have like a tiered system of like, this is really complicated, this goes to GPT-4, this is a really simple question, this goes to Haiku to save money.
Yeah, we have done that with different steps of the process where we mix and match different models, and it's definitely has big speed and cost implications of doing that. However, for the final response generation, we like to stay consistent so it's not like a jarring experience. There's kind of one voice you can expect back from the research assistant, and we're very, very cautious about changing out that model for that final step so that it stays consistent.
Thank you, Jeff.
Thank you, David.
Thank you, everyone. We have 15 minutes until the next talk.
Thanks, everybody.